Quality, safety, and reliability are critical to the success of enterprise system, because what you don't measure will fail. If you are not measuring quality, safety, and reliability, chances are there that your AI system will fail. Evals serve as the core governance framework. AI evals are code-based benchmarking mechanism for models' safety, quality, and reliability, whereas testing validates exact matches and predictable outputs. Evaluation assesses overall quality, intent, and alignment. Evals are for multi-criteria AI grading. That means input to eval is assessed on more than one criteria. Grading means a score is assigned to each criteria. So we have an AI system which, when executes, generate output. This eval system then evaluates output generated by AI system on multiple criteria such as correctness, completeness, safety, relevance, and so on, and a score is assigned to each. We may say that the output generated is 90% correct, 84% complete, and 100% safe. Let's understand how eval process works. We have execution followed by evaluation on multiple criteria, followed by scoring, followed by quality gates. Now these quality gates are very important because the score being generated is tested against a predefined standard, and only when those standards are matched the code is deployed. Otherwise, it is flagged for review. Evals turn fragile AI prototypes into a resilient enterprise software by creating an adaptive loop that continuously optimizes and aligns autonomous systems with the human intent. Agentic execution is all about making LLM calls, tool calls, RAG retrieval, and so on. The output generated is then passed to evaluation system so as to check it for relevance, safety, correctness, completeness. Score translates subjective attributes such as truthfulness, tone, or formatting into objective quantifiable metrics. Scorers evaluate system performance and return distinct metrics as numeric values. The quality gate is responsible for comparing generated scores against predefined minimum threshold, and only after changes are approved by quality gates code is pushed to production. Evaluating agentic system is different from evaluating a simple LLM. We cannot judge an AI agent by its final answer only. If it is just an LLM call, you can test the response against multiple criteria. However, agentic execution involves multiple LLM calls, tool calls, reg execution, MCP interaction, and so on, and therefore a correct output can hide flawed intermediate steps such as reasoning or broken tool calls. In other words, output might appear correct. There are several intermediate incorrect executions. So, to truly assess performance, we must evaluate the entire trajectory, the complete path execution. Evaluation of an agentic system demands the simultaneous measurement of functional performance, such as task success, tool routing, and argument precision, followed by cognitive alignment, such as planning and reasoning trajectories. This means we have to check if planning is correct, reasoning is correct. Then we have operational overhead. We have to check the latency, cost, and safety protocols. Even when an agentic system is correct and it is executing too slow, we have to reject it. Similarly, if the cost is too high, we have to reject it. So remember, we have to make sure that every LLM call, every tool call is in place. We have to make sure that planning and reasonings are working as expected. We have to make sure that latency, cost, and safety protocols are being observed. Let's understand evaluation techniques available. The first is code based evaluation, which is deterministic. Script based, it is more or less like writing unit test but for agentic system. It is ideal for verifying binary functionality. That means when the output is either yes or no, the test has succeeded or not. It is highly efficient, executes fast, and because there are no LLMs involved, there is no cost. However, it is not capable of grading performance. It struggles with open-ended generation. That means if there are many possibilities, the system may not able to decide. The second is grader based approach or LLM as a judge, where one LLM is used as a judge to evaluate the output being generated by some other LLM. It is ideal for complex reasoning and factual accuracy. Of course, there are advantages. It explains its decision by providing qualitative reasoning alongside numerical scores, rankings, or categories. However, it introduces latency due to LLM calls, and you have to pay the cost of token as well. It is always prone to bias, and therefore, prompt engineering is very important in this approach. Now, which approach should we choose? Which is effective evaluation strategy? You have to use both deterministic and grader approach. You should first apply deterministic code based filters to flag regressions and validate syntax or schemas. A regression means to test whether the current output is performing as good as the previous output. And then once deterministic algorithms are applied, we can use graders to judge subjective elements like narrative quality, tone, complex code logic, and so on. The next important thing is rubric. A rubric is a scoring guide or tool used to evaluate the quality of a piece of work. In AI context, this piece of work is agentic execution. Rubrics make judgments consistent, objective, and repeatable. Instead of answering just yes or no or just good or bad, it assigns a score to evaluate the performance with precision. It turns subjective discussions into objective one. Rubrics are used for factual accuracy and completeness. Rubrics are used for relevance and clarity. Rubrics are used to make sure that we are assigning score instead of just saying it has passed or not. There are several ways of implementing rubrics. Here is an example prompt. So you are an expert grader. Evaluate the system response using the following rubric. The first is accuracy, the second is hallucination, and then the third is completeness. And then we have assigned 5, 3, 1 scores depending on the outcome. For example, if it is 100% accurate, then assign a score of 5, and if it is mostly incorrect, then assign a score of 1. Here is a complete example where we have uses weighted calculation of the final score. So we have 1, 2, 3 criteria, that is hallucination, accuracy, and completeness, and we are giving more weightage to hallucination as compared to accuracy and completeness. we are giving 40% weightage to hallucination as compared to accuracy and completeness, which is each 30% respectively. After the evaluation has been done and scores are generated like 4 by 5, 5 by 5, we have multiplied those scores to their respective weights. So 40% of 40 is 1.6, 30% of 5 is 1.5, and finally we have calculated the average. So the overall output is 4.3 upon 5, which is 86%. Since hallucination is given more weightage than accuracy and completeness, a slight variation in hallucination might produce a different result. Let's talk about golden dataset. A golden dataset is a collection of manually verified high quality samples that defines the expected behavior of an AI application. So you need experts to create those golden data sets. For example, if you are creating golden data set for an e-commerce system, that golden data set has to be created by a person experienced in implementing e-commerce system that has complete understanding of that e-commerce system. Every time there is a change in AI system, it is tested against that golden data set, that standard data set, so as to determine if that changes has resulted in negative performance or not. A golden data set has input data, expected output, metadata, and assessment matrix. It should have a minimal of input data and expected output. The expected output is also known as ground truth. An example here, what is your refund policy? This is what user might ask, and the context is when a user is requesting refund for an item that he or she has purchased. The expected response should be the customers can request a refund within 15 days as long as they have a valid receipt. What we are creating is an array of those golden entries. A golden data set is a collection of those golden entries containing input, output, context, metadata, and so on. Let's see how we can use golden data set. Inputs from golden data set is injected into AI system. This is after the changes are being made. The AI system executes, generate a real answer for each input, and then those real answers are compared with the answers contained in golden data set. Then grading is applied. If both the answer matches, obviously grading will assign it a score of 5 on 5. If there is a total mismatch, a low score may be assigned. And then if scores are not as per expectations, refinement is applied. So you are now asked to make changes to prompt or whatever the changes you did. If you want to implement Evals, you have a number of frameworks available, and what framework will you choose depends on your priorities, whether you are into CI/CD unit testing, end-to-end evaluation, multi-turn agent tracking, red team security, granular production tracing, and so on. DeepEval is a market leader. There are some other good options as well. For example, Braintrust, Maxim AI, Promptfoo, Ragas, LangSmith, and so on. I will be creating a video on DeepEval, how we can use DeepEval metrics, GEval, golden datasets, rubrics to create a system that is capable of testing AI, to create something that is capable of evaluating an AI system. Thank you for watching this video. If you like this video, you can subscribe to 10x Roadmap for future updates. In my next video, I will be explaining how we can create an automated CI/CD based pipeline for evaluation, and how we can use DeepEval so as to evaluate an AI system. Thank you.